Been about 6 hours, and the next step is to remove the part from this little heating module and trim off some of the excess. So I've let this cool for a little bit after the heating pads were turned off. We're going to take off this counterweight. I'm going to remove the negative that was used to sort of seal the two pieces of carbon fiber together so that they would have a good bond. And we'll remove these blocks. We don't need these either. And then we're going to peel up the part, pull off this polyester from the plate below. And none of this is going to be retained, so we can afford to make a bit of a mess here. As you can see, the part comes away from the plastic pretty easily. There's a little bit of sort of vacuum adherence, but it's not bad. And as you sort of feed it off, pull it off, you reveal the part. Now, as you can see on the bottom surface, you've got a very nice flat mirror gloss finish. So we're not going to have to do any more to this surface. All the rest of the work we're going to have to do is the trimming off of the extra material and the smoothing up of the upper surface. So I'm going to remove the rest of this plastic, and then we're going to go outside and we're going to cut away this material. And the reason you want to do that outside is because it's kind of dusty. And the best way to do this is to use a Dremel tool. Outside is the best place to cut this because of the dust, and using a large cutoff wheel and a Dremel, what I do is I use the little dam or line that had been formed by the negative that kept the two pieces of carbon adherent during the gluing as the line that's going to guide me with the cut. You want to be very generous with this. You're not trying to make a final shape on the wing, you're just trying to remove the bulk excess with the Dremel. Trick here is you want to cut so that the dust is blowing down away from you rather than way into your face. It's going to be a little loud. This cuts very quickly. Not bad. Now the next step is you want to trim off the excess on the ends. And we know that we have an extra 1.5 inches on each end. So what I'm going to do is, using a red marker, which is good for black, I'm just going to mark a series of dots. It tends to be the easiest way to do this rather than trying to draw a curving line. And I'm just going to make little dots. The curving surface is hard to use a straight edge, but the dots are kind of nice. And the same thing over here. Probably easiest if I do it like this. Again, marking in 1.5 inches. Almost. And now what I'm going to do is rough cut that off. Another little trick with this is cut toward you, because the dust that comes off doesn't then end up covering up the line. That's still a little hard to see despite the fact that it's red. Cut generous of the line, because the line is where you actually want to end up with the wing. So you want to bring that finely, you want to bring that in with a sanding technique rather than the grinding technique, so cut outside of it. Turn it around. Do the same thing here, again, outside of the line. Final step is putting about a 10-degree angle on the end of the wing tends to produce a little bit less noise. And so the trick to doing that is using a board and some lineup with a protractor on a disposable board or a flat plate. You can then line up that cutoff very easily. So now I'm going to take this board on which I've marked some straight right angles as well as the 10-degree bevel that I want to put on the end of the wing, lining up the straight leading edge and the end point where the wing is going to be not cut. I then take a little piece of that 5mm polyester film and use it as sort of a curving straight edge. In this case, you can get a little bit of a curve, and then just mark it. Okay, I'm just going to want to remove that with the Dremel. Once again, stay outside the line. That's it. The next step is we're going to go inside and we're going to prepare this for smoothing. So I'll see you in just a sec. Now that we've rough cut this with a Dremel, the next step is to sand it to a higher precision. And the best way to do that is to use a sanding board. You can get some small ones from, say, auto repair shops. What I'm using is called a long board. It's frequently used for making yachts and large structures. And the good thing about this is it has a lot of surface area, so it takes a long time to bog up the paper. More importantly, though, because of its very large size, it's easy to perfect your angles. You can see it very easily when you do it. And the other trick is when you're using it, always have your hand above the area where you're sanding. Don't put it way over here where you tend to kind of wiggle a lot. And then put this over the end, hold your part a little bit over the end of the table, and then just draw it back and forth. Draw it in line with the cord, because if you draw it up and down, you have a tendency to pull the carbon away from the foam. Keep bringing it back and forth and try to be as sort of square with the floor and square with the wing. And you can see in just a couple passes, you end up bringing it right to where that red line was. Not quite, but very close. This doesn't take long. If you overdo it, don't worry about it. The change is easily reconcilable with the other wing. Turn it around and repeat the action on the other end, and you're just going to bring it to a flat surface, up and down being square with the surface of the paper. And this prevents you from doing a lot of rounding action like you might with a shorter board. The only error you might make, again, is this sort of tip, so you kind of want to eyeball it to make sure you're not leaning into it. Okay, done with that part. Now the next step is where the styrofoam had been used to form a little dam or a little support to keep the two layers of carbon together, you tend to get a little bit of a ridge where the epoxy had settled. You want to remove some of that material, so let the wing hang a little bit over the end of a table. And then what you're going to do is you're going to draw it back. You don't push it up, but you're going to draw it back. And you start at an angle that's going to end up being pretty divergent from the surface of the wing. And you're just going to pull it back. Maybe just 2 strokes might be enough. And you'll find that this is done mostly by feel. You'll feel the surface and you'll feel the ridge disappearing. As you progress with a couple of draws and this ridge becomes very small, what you'll do is you'll tend to start making it more and more in parallel with the trailing surface of the wing. When you get to the actual angle of the wing, you'll see that the abrasion starts to mark up the top surface here. Don't worry about that. That's actually where you want to be. But you want to get there at the end of your action. When you're done with that, you're going to get rid of this ridge. And you can do this all the way along the length here. Doesn't take long. And bringing it back and forth across here a couple of times, you're going to end up with a pretty smooth surface. Pretty fair surface, I should say. Back and forth. This is one advantage of that long board, because you're not going to fill up the paper with this little bit of epoxy. And you'll notice that the dust that's coming off of here is white. That's a real important thing because the epoxy is sacrificial. You don't care about that. You care about the carbon. And so if you overdo this, you're going to start getting a gray and then black powder. It's not going to kill you. It's not going to destroy the wing, but it's an end point. You don't really want to dig into carbon any more than necessary. Now you continue with this for a while. Depending on how deep the ridge is, it could take 2 or 3 minutes. But you can feel it's almost gone. I've got some typical laminating resin. And what I'm going to do is I'm going to add to this a material called Cabasil or fumed silica. You can get pre-thickened epoxy as a tube or as a dispensed item. But what this does, a very lightweight powder, it's very small microscopic particles of glass. And they tend to really thicken up a epoxy mixture so that you can turn it into a paste that doesn't settle with gravity. And I'm using a fast set epoxy, so I have to move kind of quickly, but I don't have much to do here. So that'll make it very easy to move to the next step without a lot of delay. Mix this in until it won't run anymore. Excuse me, a little dusty. Stuff does get in the air. Now the fast set epoxies set so quickly that you can already feel it starting to get a little bit warm in the container. So you don't have much time to work. In some cases the filler actually ends up cooling the mixture and kind of delaying the curing process. But the mass of this stuff is so low that that doesn't happen. You don't get that extra time factor. This is probably going to be enough. See, it doesn't run. Now what you're going to do is take a little bit of this, very little bit of it, and you're going to push it into the end of the defect that you just gouged into the end of the wing. And you don't have to be neat here because you actually want it to be kind of blobby. You want it to stick over the edges and actually cover the free ends of the carbon so that it's very easy to get a very fair end of your wing when the time comes. So don't be stingy. This stuff will sand off in about 30 seconds when the time comes. So being generous here is going to eliminate the likelihood that you're going to have to do this twice. Now once you're done with that, then you can bring this over to your table where you'd originally done the gluing. I've got a fresh piece of polyester down here so it doesn't stick. I'm going to place this down onto the surface like this. And then what I'm going to do is mix up a coating of epoxy and we're going to coat this wing. So I'm ready to put on the last coat that's just about done being mixed. And one thing I'd like to say is for those of you who are intimidated by the number of steps, thinking that there's no way that you'd ever be able to do this, realize that there are a number of steps, but they're all fairly simple and they're quite quick. And keep in mind that this wing as it stands right now, if I wiped that epoxy off the end and bolted it onto a hub, would perform at about 90 to 95% of its ultimate capability, even with the rough cut edge, even without any kind of smoothing. Because the efficiency of that wing has been determined by the shape, and that was given to you by the foam core. And the strength is the foam core graphite combination, and that's already there. Almost everything that we're doing from this point forward is for aesthetic purposes, to make it look really nice. So you can do this, and if you watch this video maybe once or twice, follow the steps, I almost guarantee that the first wing that you produce will be excellent. and the third and the fourth wings that you produce will be excellent as well, but also be a little bit easier and you'll be faster. Another little trick with epoxy is that the speed of the curing of epoxy is often specified on its pot length. And that means how long it can remain in a pot before it becomes unworkable. That can be extended enormously if you get the bulk of the material spread out onto into a thin layer and out of the pot, because the curing process is exothermic and it tends to heat, and then the curing speeds up and it continues to heat in a sort of vicious cycle. If you can get the material out of the pot and on a thin surface so that it remains cool and the heat can be transmitted down into the underlying surface, the pot life can be extended to a working life that could be 3 or 4 times as large. So get the bulk down onto the material that you're going to be covering, and then you can fine-tune the edges and the little parts that you missed with the material that you've already got down there. Now, any brush strokes that I create here are going to disappear with gravity. They're just going to flow out. And most of this epoxy that you're adding is going to be taken off. But because we've added more to the areas that are depressed, it tends to settle in those areas, you're going to have a lot less effort when you finally finish this than you would if you tried to dig down through the layers of epoxy that were there in order to get to the lowest levels and make everything smooth. And so even though it's an extra step, it's actually faster. And you can be relatively generous here, because that will just ensure that you're not going to have to do this twice. And you can tell already that the surface is looking glassy and almost perfect. Look at it sometimes from different angles as the light reflects off it, and you'll see where you might have missed something. Make sure it runs over the leading edge, but you don't have to make a huge dam, because some of it's going to tend to run down there anyway. Nice. That's it. Another thing is, when you have it in a pot like this, it's going to tend to overheat, and you might put it aside and think, I'll get to that later. This can get hot enough to melt the cup and even start on fire if you let it sit in a large solid volume like this. So a good idea at this point is just pour it into a garbage can or some disposal so you spread it out and it cures slowly over a period of time. So the last step, just like before, so I don't have to wait a long time, is I put my little heater on, my little insulating towel, and by using heat, in addition to a little bit faster cure epoxy, this should be ready for final finishing in about 2.5 hours. See you then. The next step is we're going to take the cured wing off of the jig where it was glued, heated, and cured. And before I remove it, I'm just going to have you take a close look at the surface, how much smoother it is than it was after the first coating of the epoxy. This is the real advantage of taking this extra step as opposed to trying to muscle it out and get that epoxy and carbon down to a smooth surface. It also does another thing, and it protects you from damaging the carbon structure underneath the epoxy by giving you a thicker layer of sacrificial material. One thing that I'll warn you against in the process of trying to make this as efficient as possible, one experiment that I undertook and it failed, was to take a longer piece of polyester film and draw it over along with the carbon film over the carbon fiber in order to try to impose a smooth surface on the upper side as well as the lower. Problem with that is that the gooey, syrupy epoxy cloth really sticks to the polyester very, very well. And unless you're absolutely perfect in your drawing pattern, you tend to introduce wrinkles or defects that are very hard to manipulate when this is still in a syrupy state. So you end up getting a smoother surface, but you end up with some defects that nevertheless require that you do the sanding anyway. So it's a step that doesn't save you any time. Another trick I tried, which was to take one of the negatives from the manufacturer, sand it, coat it with epoxy, put mold release material on this so that it became slippery and wouldn't stick to the epoxy, and then using this on top, trying to impose a smooth surface on it. theoretically, it's not a bad idea. The problem with that, though, is unless, again, you put it down absolutely perfectly, you tend to capture little air bubbles and defects between the two surfaces. Again, you still have to go through this finishing step, and so, neat idea, but it doesn't really save any time. This keep it simple, stupid theory is actually not a bad one in this case. So what I'm going to do is I'm going to pull the carbon off of the polyester. It's taped down here, so this may take a little bit of effort, but usually it's not too bad. And as you pull it up, you'll see that some flashing comes with it. This is the epoxy that sort of came off the sides. But this is easily removed, and what we're going to do is we're going to go over to the sanding table and do that. The material is very thin. You can just sand this off with the longboard and it'll come off, but if you've got a fairly thick flashing, you'll save some time if you just cut the bulk of it off with the Dremel tool. Don't have to really do this one so much outside anymore because you're not going to be cutting through any carbon, just the epoxy. It's kind of thin. So it's going to be a little noisy though, so be prepared for that. And cut long because the Dremel is very imprecise. So you don't want to cut through the carbon. It's dusty, but this dust is pretty benign. And I'll just do that on the other side too. Again, if you were very judicious in your use of epoxy, you might not have to do this. But I'd rather have too much epoxy rather than have to redo that previous step. Be careful of your leading edge here. Good. Now what we're going to do is I'm going to take the longboard that we used before, and I'm just going to square up this end by just drawing it back and forth a few times. And this will help to even out that trailing edge. Sometimes bringing it down and bringing it up will give you fresh material and it'll cut a little faster. But resist the temptation to sort of work in one area because you want to try to bring it across to a nice straight surface. The longboard is wonderful for achieving that. That's nice. Okay, so now what we're going to do is, in spite of the fact that this is glassy smooth, it isn't perfectly level. So I'm going to take some of these sand foam brushes, which tend to be a little bit more aggressive than the one that I demonstrated in the previous video. And what we're going to do is just draw this over the surface. And as we do, once again, you're going to see areas that don't tend to be as evenly abraded as others. Resist the temptation to dig in where it seems like it's not digging in, because there's a reason for that. There's a ridge or there's some high point, and you'll get the best possible quality in the long run if you're very even-handed in the way that you do the sanding. The little ridge on the back is tending to keep me up a little bit, and so that's why I'm getting most of my sanding abrasion here. But again, if you're pretty fair-handed about this, obviously this isn't taking very long. And you just keep going across it like this. And try to vary your strokes too, because it tends to keep you, again, a little bit more honest, and you don't tend to be prejudicial to one area or the other. Another little trick I use, you can see how I'm kind of dancing this around. Take one of these carpenter's pads. It's often used when you're woodworking and you're putting a piece of board on a board. They slip more. This stuff is wonderful because it provides a lot of friction. Keep it from sticking out over the surface. And you notice how this is sliding around a lot less. Now you'll still see some areas that are uneven. They'll come out. Now, as easy as I say this is, understand you will build up some muscles if you're going to do enough propellers for an octocopter. But compared to about $2,000 worth of blades, it's a nice alternative to going to the health club. Turning this over will give you some fresh material and it tends to cut a little bit more quickly, but this material is actually still pretty good. Take a little vacuum cleaner and pull that stuff out and it'll work a lot better. Now, I'm not forgetting the root, it's just that I'm sitting on the bench here where this is a little bit easier to get at. And there's nothing wrong with you turning it around if you want to get the bulk of the material on the other end. Ultimately, you're going to want to do the leading edge, and the best way to get that anyway is, again, to hang it over. So you have a tendency to do this. You don't want to be grinding the leading edge this way. You always want to be going in the direction that air travels. If you get a lot of dust or sort of epoxy residue on here that can make it a little hard to see where you need to go, you can take a little bit of alcohol or water and just rinse it off and let it dry. And that tends to make it just a little bit easier to see where you're missing anything if you are. Again, change your patterns whenever possible. It tends to keep you honest. I'm going to bring this around again and come around like this in order to get this part. Now, right near the hub, that thickener that I put in, that doubler, is going to mean you're going to get a little ridge here. Doesn't really matter. It's traveling very slow. It's near the hub. But even so, it's going to be pretty hard to detect when you're done sanding. Now you can see it's disappearing, or the defects are, near the back edge as I keep bringing it back. But resist the temptation to work in one spot, because you want a very even, smooth wing. Despite the work, I can tell that this is going to work better even than the first couple of wings I made for myself, simply because I used that thicker, more viscous epoxy than the thinner epoxy which I used in the first layup, because it gives you a little thicker layer. Notice also white. I'm really not cutting into the carbon. This is important because you don't want to damage the underlying structure. We're removing weight here, actually, which is a good thing, but we're not removing any strength. As soon as you start digging into the carbon, you can do that, but just be aware that you're starting to get into the structure, and you want to be kind of careful about that. And as I said before, in the words of Douglas Adams, don't panic. Your wing here is going to work as well now as it ever would. This little bit of extra smoothing and everything you're doing is really just aesthetic. The little bit of roughness is going to be even hard to detect once you finish the next step. We're going to keep doing this for a while. I'm only going to have to do a very light brushing on the other side because it's already almost perfect. And when we come back to you, what we'll do is I'll show you how we continue to smooth this out to make this really nice. All right, now I'm finishing up with the block, and pretty much the blocks are what you use to get the level. They're not going to be the final way to get the really finest, smoothest surface, because they just don't make them that fine. There's a little defect there. You can barely feel it, but I don't think I'm going to continue to dig there, and it's really not going to have any effect on the performance. Also, for this demo, if you wanted to spend a couple more minutes, you could probably get that out, and then you'd have, a really gorgeous shape. But we've gotten the shape pretty much assured by just using the block. And then what you're going to do is you want to get the end nicely finished. I had done this just with the by hand before, but now using the block here, you're going to want to bring this around so you get a nice, smooth, even surface. And always watch out for carbon, because that means you're as deep as you better go. I still have a little defect there, but that'll come out if I just continue to sort of round the edge off. And any variation in the weight between the two, because obviously this is being done by hand, will be taken care of in the last step, which is the balancing stage. So you don't have to worry too much about, well, did I take off another ½ gram than I should have or something like that? That's not going to matter. Now, if you're really compulsive, you'll drive yourself nuts, but you don't have to be. Now, the next step, you can either just go right to a different grit, you can clean it off to see what you're going to end up with. But basically what happens is you're going to spend about a minute to a minute and a half with each subsequent layer or sanding just to remove the depth of the previous sanding's scratches. So you'll feel, this is almost all textural. You'll feel the surface. You'll feel that it feels kind of satiny right now, and that's with about 150 grit. Then if you start going up in higher grits, all you're going to accomplish is removing one layer of scratches and converting it into another layer of scratches. So this is very, very fast. Hardly going to do anything to it. Just like this. I'm pretty much done with this grit in that area. It's that fast. And you can even feel how smooth it is. And that's probably the best way to tell if you're done with this level. This is 220. I'll go over the surface. And obviously you're going to want to do this on both surfaces. Just bring it up all the way across. And we're just getting it smoother. You'll see you can detect a little ridge there where the hub is. That's not going to matter. And then around the leading edge, sometimes it's a nice thing to just bring it around like this. And what you're doing is you're making sure you didn't leave any small, rough spots on the leading edge. Okay, there we go. Now when you touch it, you get a little bit of skin oil on it, and that also makes it look a little bit kind of modelly. Wipe it down again to remove that last layer. And then what you're going to want to do, you can see I'm taking a little bit of carbon, but very little. It's not going to make any difference. Then immediately, you're done with that, and I'm going to 400 grit. And you're going to continue this process of going smoother and smoother. Typically, about 1,000 grit, meaning maybe one more beyond this, is going to be enough. These microscopic deviations, I can't feel them. And so what will happen is on the final step, whether you paint it or whether you coat it, those will go away as well. And you can tell here, this is feeling almost glassy. Again, the leading edge, don't forget about it. Try to randomize some of your directions. You can't really feel this, but this feels really nice now. It feels almost glossy. Very random. This is not sort of has to be in one direction. Then again, a little bit more alcohol, just because partially I'm removing any grit that may have existed before too. I don't want to take any of the other grit and carry it through to the next step. Then I'm going to 1,000 grit. And you can see these subsequent grits are very, very quick. They don't take hardly any time at all. And as you dry it, you can see that it becomes again more matte. Again, I'm going to rub it, and again, you'll feel the difference. It's just a tactile thing. Each one of these stages, I think I would say, take about 2 minutes. Most of your time is going to be that smoothing that you did with the sanding blocks, and depending on how muscular you are and also how much epoxy you put on, that can vary anywhere from about 10 minutes to about 25. And again, the leading edge, just sort of roll over it. And you notice how I'm trying to sort of scrape across in an angle and kind of vary the angle so that I don't get a tendency to sort of dig in one area. I want to be as even-handed as possible. Now you could carry this another grit higher. You could go all the way to 2000 if you wanted to. It isn't really necessary for the very last step that we're going to take. And that is, we're going to clean off the wing, and we're going to go ahead and we're going to put on the last coat of sealing epoxy. Now if you wanted to at this point, and you wanted to paint it like I did the first wing I did, you would stop here and it would be ready for priming and painting. But if you want to see the nice carbon structure underneath, which is obviously beautiful, then coating it with an extremely thin layer of a final epoxy will make it look like it does when it's wet. So that's the next step. We're going to go over to a little stand, and I'm going to apply a very thin coat, final coat of epoxy. Put the epoxy over the surface and give yourself a very glassy, smooth surface. And the trick with this is you can put it on a little thicker than you think you might end up with, because you want to spread it around, you want to make sure you wet the whole surface. But you're going to remove almost all of it when you're done, because all you want is a couple of microns to fill the scratches. And a little trick too is that the leading edge will tend to pull epoxy off your brush. So you don't want to put a lot of bubbles up there that are going to sort of drip down over the surface when you're done. And any kind of brush strokes here will fade away over time just with gravity. And so get it applied, and then the last step after you've applied it is actually going to remove about 90% of it with the same foam brush. Just want to get it coated, get it covered. And I said you want to be very careful about the leading edge. If I do this, you'll see I'll intentionally do it. You'll get sort of a bubble that will build up behind there and some runs, and that's what you don't want. Now we can obviously fix that now, but you want to be persistently aware of that as you kind of go side to side, looking back and forth to see if you can find some defects. But once you've pretty much covered the entire surface, look at it from different angles to make sure that you haven't missed it, because it's a lot easier to see this if you see the surface from different angles. But once you get the whole thing covered, then what you're going to want to do is you're going to want to remove most of it. And the way you do that is you start drying out the brush in the pot or the cup, and then you're going to draw it back over. Each time you're pulling off more epoxy, because all you want is to make it look wet. You don't really need any kind of protective layer. You're just filling in the scratches. And you want to do this 2 or 3 times if you want to get it really good, but if you're pretty aggressive about it, you can get away with just 1 time. And again, look on the other surface, make sure you haven't sort of left a big bubble there. But you're going to get as much of this off as you possibly can, and then allow gravity to give you a nice glassy finish when you're all done. And you'll be surprised if you change your angle, your point of view, how you can miss things. You'll think, oh, that looks great, and then you look from a different point of view and you'll see little mistakes you made. Again, don't worry about the brush strokes or the little ridges you see made by the foam brush. They will go away. But you don't want to go too long with this step with a short pot life epoxy, because you do want that time for those brush strokes to disappear. If you don't give it enough time, they won't, because they'll start curing and getting gelatinous before they've had a chance to even out. And also check your trailing edge, make sure that you haven't sort of left little drips hanging down there. I'm doing actually very well, not missing too much. And as you can see, I keep going over this. Now I could do this for a little bit longer, and I'll probably remove another half cc of material. But we're getting pretty close to being done with this. Now the last thing we're going to do after this cures is we're going to balance the props. And balancing is quite easy. And what you have to do is you have to manufacture a hub or have some way to balance them. And what I found is in almost all of these asymmetrical airfoils, the typical 6 to 10 degrees angle of attack gives you almost the same performance. Theoretically and also practically. So I picked 8 degrees as sort of the optimum because it's just a nice basic point to start from. And I've manufactured some hubs that work very well to hold these wings based on this hard point that we've manufactured into the individual wings. If you have a mill, it's very easy to do. If you have a CNC mill, it's very easy to do quickly. But nevertheless, some people who don't have mills, it may be a little bit of a struggle for you to try to do that. If you're very interested in pursuing this and you'd like to make some of these wings and you'd like to invest the time in the composite part, drop us a line, and we could probably work something out where we can make some hubs for you, because I'd like to see a number of people who are following this channel follow up on this and see if they can make some multi-rotors work with this kind of design. Nevertheless, we have to balance it, and so I'm going to show you a finished wing mounted on one of our hubs, and I'll show you how we balance it. It's actually pretty easy to do. Now, these particular hubs were made for the Carnegie motors that we're using on our multi-rotors, and so they specifically have a certain bolt pattern. They're light-weighted, and they have a reduced weight for the clamping area over here. They've also been relieved underneath the bolts, so that what ends up happening is when you press here, you don't just depend on the friction of this upper surface with this washer, which can obviously turn, but there's actually an indentation on the other side of this material, so that what ends up happening is as you pull it down to the surface, you're actually resting it on a rim of aluminum underneath here to prevent it from twisting once you've locked it down in a perfect alignment. These are simply lightning holes that make the whole part weigh a little bit less. And as you can tell from the end here, I'll show you, they're at an 8-degree angle. And this particular hub can be used, obviously, depending on which direction you spin it, both for clockwise and counterclockwise operation. Now, to balance this, what we're going to do is we're going to mount this in one of these balancing jigs on its center hole, and intentionally I've sort of misbalanced these things by adding a little bit of weight here underneath the wing. They're actually a little closer than they appear to be, simply because I want to do this demonstration. Now, the way to balance this is once you put this into the hub and you've aligned the leading edges perfectly straight, because there is no taper here. The only thing that would end up being a problem for balance must be the wings themselves, and as you can see, this wing is heavy. So what we need to do is we need to add weight to the other wing. And so when we spin this wing around like this, the way I do it is I take a piece of cellophane tape and I mount the tape, say about 1 centimeter or 2 inward from the trailing edge of the outer end of the blade. And then I take a brass rod. This one turns out to be 1 millimeter in diameter. And I trim off a generous portion, something that I know is going to end up being too long. And this will weigh that wing, and I see that now I know that I have too much weight over here. But I know that when I insert it, it's about the center point of where this is going to be. Probably should mount the tape out a little bit more, actually, to be really good about it. Once I do that, then I take a wire cutter and I cut off progressive pieces of this brass until I get the wings to balance. What's nice is you don't have to do this perfectly, because what you'll find is that if you do leave a little bit of imbalance in these wings, the fact that you're bolting them here provides you an opportunity to add a washer if you wanted to bring this out and say you don't want to try to nail this. But clearly it's too heavy, so we'll keep cutting it. And it's always better to cut than to try to have to get a new one, so you always want to be a little bit conservative. And as you continue to cut, you'll eventually reach a point where it pretty much hovers. As you can tell, we don't need much. The wings are actually pretty close. Now they're getting pretty close. Take off a little bit more. This tape is annoying. It's still a tiny bit heavy, but very close. It'll end up being my finger oil that's going to be the difference here. I mean, that's pretty much perfect. So the next step, it's me blowing on it. The next step is how to mount this in here. There's a little trick for that too. What we're going to do is we're going to take a drill of the same gauge as this brass, And we're going to simply drill a little hole in the end of the wing. What I'm going to do is I'm going to make a little indentation so that the drill doesn't slide around. And pretty much I just put it in the thickest part of the wing, simply because if I put it in the thickest part of the wing, I'm going to have more leeway in case I don't drill perfectly. So I have a little device here that helps me to do that. It provides a little bit of a indentation without producing a lot of pressure. And then at that point of the indentation, what I do is I take the drill and I'm going to drill through the plastic at that point and into the foam underneath. You'll feel when it goes. There. Then I take my little brass rod and I insert that in there. Get it a little bit below the surface. Not much, just a little bit so it's still in the plastic. And then I take a little bit of an instant set epoxy and I place a little dab right over the hole. Just like that. And then, with my gloved hand, I finish the wing. And we're done. Now the last step that we're going to take is to test these wings, as I promised. I'm not just going to fabricate them, but I'm going to prove whether or not these wings are any good relative to the commercial wings. So when we have the setup up outside, what we're going to do is we're going to test each wing. We're going to measure the propulsive efficiency, we're going to measure the weight, we're going to measure the noise levels when they operate, and you'll also get an idea of what the vibration is just from the way that the meters run, and hopefully that'll give you an idea of the comparative effectiveness of whether or not you want to build or whether or not you want to buy. So thanks very much for being patient. Hopefully, even if this isn't useful just for propellers, it may be useful for building anything that has an airfoil or anything that requires small carbon fiber work. You can probably use some of these skills elsewhere as well. Thanks so much for watching. Good night.